Hello everyone, welcome to another video of Naukri learning. Today we are going to look at what is Git version control system and how you can use that in your system. So before proceeding, let us understand what version control systems are. These are infrastructures which are created to maintain and track all the changes to your files and folders at a given point of time, and they are able to maintain the history of all the changes that you have ever made to these folders and files. So infrastructures like Google Drive and Dropbox can also be treated as a version control systems because they are able to maintain the history of all the changes that you have done in your files, and they are able to retrieve those checkpoints if you want to go back to some other versions which you have previously made changes to. So let us understand how version control systems have evolved. So Git is an open source free software which is an example of distributed version control systems. So prior to this, we had central version control systems over where we had a client and we had a server. The client used to request to the server to get a piece of code. They have to edit on it and then again push back to the server. Server was the main repository or the main location where the history of all the files was tracked. So when we say repository, it's a set of files or a folder structure for which you want to have a track of all the changes that you are creating on top of it. So for a centralized version control system, if there were two users, they have to be simultaneously connected to the server. Then they have to ask for update of the latest file that they want to edit on. They then used to do some changes on it and then push it back to the server. There were no two-way communication between two users about what all the changes that they are doing. And anyone who is maintaining the final repository has the overview, or they were in charge of changing and collating all the changes that system A and system B has done on top of it. And there was only one place where all the history was tracked, and that was the server repository. Then came the distributed version control system. Over here, what happens is each user who wants to change anything on the repository have to clone the repository in their local machines. They have this entire history, entire set and entire branch of the repository with all the codes in their local repository. And then they can do changes on top of it, and then they can commit the changes in their own repositories, which is a clone of the actual repository. And then if they wish, they can push it back to the final repository. So the main difference is previously we had only one server which was tracking all the histories and which was responsible for making the track of histories. But right now we have, for each user who is trying to make any change, they all have the history and they all have the entire snapshot of the codes that they are work upon, along with all the changes and all the branches that have ever been pushed to the final repository. This way, we also have a fault-proof system that if at any time our main server goes down, each user will have a copy of the entire code, all the branches, and all the history of changes that has ever been made, so that they can again roll it back and push it to the main servers. A few additional distinctions between centralized version control systems and distributed version control systems are that previously in centralized version control systems, each user has to be always connected with the server in order to push and request for the latest files. And they have also been situations in which each user have to be really cautious and have to have a good communication with all the users that are interacting with the server in order to make some changes in a file or in the folder structure. However, in the distributed version control systems, a user can even be offline and still make changes in the files. And later on, once they have the bandwidth and they are able to come online again, they can push the entire structure to the final server repository. This also eliminated the need to communicate with all the users simultaneously while you are making some changes in the codes. And since Git was a very good example of distributed version control systems, and it came with all the advantages that a distributed version control system has to offer, soon the industry started moving their codes and track their versions using Git. So let us understand a few of the features of Git. As we discussed, it's a distributed version control system, so it comes with all the flexibilities of distributed version control systems, And that's why more or less all the tech giants and the programming companies are using Git as the primary version control system. It is also secure, so each commit can be traced back via a unique ID. So we'll discuss more about what is commit. It is open sourced, so you can download the Git and host it in your own servers if you want. It allows branches, merging, and non-linear development. We'll also see about what branches and mergings are. It has good support of conflict resolution. So anytime two users commit on a same file and they are writing some different things, so it has really good infrastructure to detect those and help us resolve those conflicts. It's really speedy and it's already scalable. It provides a staging area. So a staging area is a preview of all the changes that you have done and whether you want to put that as a checkpoint or not. Okay. It allows offline working, which is one of the primary highlights of distributed version control systems. And it allows great collaboration among all the peers who are pushing some changes on one particular file. So let us move to a few of the jargons on Git. First would be branch. So branch is a copy of the main code file, which can act as a separate repository or any little feature or a separate code base of its own altogether. Next is a checkout. Checkout is a Git command which lets you switch between branches. So, but make sure when you are switching between branches, make sure you have all your changes committed to that particular branch while switching. Cloning is copying the entire repository in your local machine or any workstation. So anyone who has the right and access to the particular repository will be able to clone this in their local machine. Fetch. So when you're in your local machine and if you have cloned one particular branch, once you do git fetch, it updates the code from the cloud repository to your own local machine at that particular time. Fork is again copying the entire repository from one GitHub account to some other GitHub account, which is more like cloning, but for those who do not have the write or read access from a particular repository and who are not a contributor of that particular repository, they can fork it. Head gives you the latest commit that you have made to a particular repository. Index is a file or a staging area where all your changes can be staged. It acts more like a preview to your changes that you have made before you commit them, before make a checkpoint out of it. Master is usually referred to the final file or the final code base that you want to refer or that is into production. Okay. Merging is like, so once you make some changes to your file, you want it to be merged back to the main file or back to the production code environment. So what you do is you merge that particular change in that code base. Origin is usually referred to the cloud server or the final repository file which you want to refer and where the stable code is. Usually it's the final repository server in your production environment. Next is pull or pull request. So say if you were making some changes, so you were adding some new features to your main code base, so you have created a branch out of it. Okay, you have added some changes on that branch and now you want to merge it back to your main branch. So what you do is you raise a pull request. You ask the main administrator, so could you please pull all my changes into this main repository, and you raise a pull request. It goes via reviews and approvals and conflict checks. Once it passes all of them, they are finally good to go in your main branch. Push is again, pushing some changes to your repository. It's more like you have your own clone and you are pushing your changes from your repository to some other branch or some other repository which is in the cloud. So rebasing allows us to move and combine sequence of commits and again push them as a single commit to the branch. Remote defines the remote location of the repository. So if you have cloned from a cloud repository to your local machine, then your machine is a local remote copy of it. So repository is a folder-like structure in which all the files and the repository itself is getting tracked and version controlled. Stashing defines a checkpoint which you can go back to. So say you were writing some changes in the code, and all of a sudden you found some bug which was related to the previous release. But now you need to roll back all your changes that you have done on top of it, just because you want to fix some random bugs which was related to a previous release. So you stash your changes, or you say, okay, hold on to these changes for some time. Let me work on some quick fixes, and I will get back to these changes after some time. So that is what stashing is. So it allows you to move your current changes on hold for some time, roll back to some previous version, do some quick fixes, and come back to this latest version that you have been developing for a while and start working on it again. Tags are essentially release notes or some important checkpoints that you want to show in your project, that these were some major releases that you can go to. So those are tags. Next, we will see how you can set up Git in your PC, how you can download Git, and how you can use Git via GitHub. So GitHub is an online platform which offers Git hostings. It is one of the free platforms and one of the widely used platforms. So we will see how you can use GitHub with your local machines. So to download Git to your local machine, all you need to do is you can search in Google. And you will see this particular link. Over here, you can choose for which operating system you want to download for. You can download for Windows, Linux, or Mac OS. So once you have this particular software downloaded, you can go ahead and install it via whichever method suits you. You can go to github.com. It's a free platform for GitHub Git hostings, and you can create your own repositories, track your codes via this online platform, and also clone these repositories to your local machines. So if you are not signed up over here, you can go ahead and sign up in this platform, or you can simply sign in if you already have an account. Okay, so I'm going to just simply sign in right now. Cool. So once you are signed in, you will be able to see all the repositories if you have created, or you will be able to create a new repository. So repository is a folder which will have all the files that you want to track. Okay. You can give some ABC repository name, anything that you want. You can give a short description about the repository that you're creating. It can be a description about the project that you want to create for. You can choose whether everybody on GitHub can view this repository or not, or you can keep it as a private repository. So for now, we'll just go ahead with private repository. Then you can add a sample README file. So README files are description about the repository, what are functions are there, some fancy stuff and fancy writing that you can do over here. Git ignore files. So this gives us a template of what kind of files do you want to not get tracked off. So in Python, there are multiple cache files or any ID related files which you don't want to put to git.py cache files and all the stuff which you can ignore in your standard templates. Then if you want to make it a public repository, then you can choose what kind of licensing for this software you can use. Okay, and then you can go ahead and create a repository. So I have few repositories created, so I will just take one of the sample repository and use that as an example. Okay, so this is one of my private repositories which we will share with you in this description of the video. Okay, so over here I have few files, which is the git ignore file. All the files in my local machines which I do not want to commit to this branch is called a git ignore file. And then I have readme.md files, which is this particular file itself, where we have written the description about this video. Okay, over here I'm going to you can see this particular part. This defines the branch. Okay, you can create multiple branch out of it, so each branch can serve a different purpose, and you can create tags as well. Okay, you can add new tags, release updates, or any versions that you want to highlight to the user. Now, in order to download this particular repository in your local, there are a few methods that you can do. One is you can go ahead and download GitHub desktop app. So this is a very interactive tool which allows you to clone your repositories and do all the stuff like merging, pulling, create branching, and pushing to the final repository in a single go, and it's very intuitive and interactive. So this is one way that we are going to look at, and then we will also see how we can do it by command line. So if you want to, you can go ahead and download this. So this is available for only Windows and Mac OS. If you are using Linux, then you have to do it via the command line. So let us see how you can clone a repository via GitHub desktop. And if you want to skip to the command line part where we clone repositories and manipulate it via command line, we will provide you the timestamp to skip over that part. Okay. So once you have downloaded the GitHub desktop, or for Windows or Mac OS, you can open it and you will see a windows like this. Okay. Over here, you will have all the repositories name, the current branch that you are pulling, what was the last time you have pulled particular branch. So if you do not have anything set up for right now, these will not show up. It will ask you to clone a new repository. Okay, so I want to clone a repository. It allows, it lets me shows me all the repositories in my GitHub account. Okay, so I want to clone the Git overview repository. It lets me choose the path where we want to clone this entire files in our local machine. So I'm good with this particular path, and I can clone. Okay. Also, you can give the URL of a particular repository. So if you go to your repository, if you go to code, you will be able to see a clone link. Okay. So if this is a private repository, then only you will be able to access it, or anyone who has contributed to this particular repository or have an access token to this repository will be able to clone it. Otherwise, if it's a public repository, then anyone can clone it in their local machines. So we'll just copy this link and go to our GitHub desktop, and you can paste the URL of the link. Okay, this is the same thing. I'm just doing it via this method. Okay, we'll just clone this repository. So it shows me that it has been cloned, and right now there is just one branch, which is main branch, and it fetched from the origin right away. Okay, so if you go to your file system, in that particular folder, you will be able to see the repository that you just cloned. For me, it's the Git overview. So I have this particular repository right away in my desktop. Okay, now if you want to go ahead and make some changes with it, you can open it with any interpreter. So I prefer VS Code for this. I will just go ahead with VS Code right now. Also, you can do it with any Python interpreter or Java interpreter like Eclipse. Okay, so anything is fine. Okay, once you open it with VS Code, it will ask you whether you trust this file. I'll just say, yeah, I trust it. Okay, so once you open it with any ID, you will be able to see its content. So I'm just opening the readme file for now. So over here I can see the preview of the file and what we have cloned from there. Okay, also most of the IDs will have an integrated solution with Git or GitHub. Okay, over here as well you will be able to see that it's able to detect that we are in the main branch, and this is for the version control system. So if you have Git linked with your VS Code, then you will be also able to do all the stuff from VS Code itself. Okay, so let's do one thing. We will check out this branch and make a development branch from here. Okay, we'll say that we are making a dev branch. once you make this branch, all the changes in this particular repository are going to go to the development branch. So what we will do is we will create a new text file, say dev.text, and we will just do it, and it can be empty file. So over here in the GitHub desktop app, we are able to see that we have created a new branch and it has detected those changes. Now what we can do is we can write a short note about this changes that we are making, new branch and test file. Okay, so this is a bigger description that you can write in your comment summary, and then you can push it to the actual repository in the origin. So it will push all the changes in your main repository. Okay, so once it has pushed all the changes to your repository, if you go to your repository and just refresh it once, you will be able to see that there is a new branch created. Okay, so in this particular drop down, you will be able to see a new branch called dev and a main branch. Okay, similarly, if you now say the next thing, let us look at how changes are viewed over here. I'm writing a random text file. I will save this file, I'll close this, and again I will go to the GitHub desktop. Right now you will be able to see that it has shown you the differences that was previously there and what things got added. Okay, so this is a new line that got added, so it's showing a plus symbol and the changes that you made to this line. Okay, we will again say sample commit, and we will add this file. So this is the staging area. Okay, so this is the staging area that where you are able to see all the previews of the changes that you were seeing. And now again commit to the main branch and we'll push it. Now what we'll do, we will make some random changes on this line. We will write notes over here and adding adding a new line. Okay, now if you go to your staging area, you will be seeing that we have removed one line, we have added one line, and we have added another line. So this is how you are able to see all the changes. And we are committing this, we are pushing this to origin. Okay, it got pushed to the origin. We will switch our branches to main. Okay, and now we are able to see that there is a new file called dev.text, and if you go inside it, you will be able to see the changes that we have done. Also, it also gives you the commit history. Remember, we mentioned about commit history tag ID. So this is a unique ID for this commit. Okay, you can go to history and check all the commits that were made to this particular file. Over here, you will be able to see the differences and the code at that point of time. Okay, so let's see the file at that point of time. So it was an empty file at that point of time. Okay, so next change. This was the next change, and this is the latest change. Okay. Also, this particular symbol will let you view the repository, the entire repository, all of the files at that particular time. So say if any of your code broke, okay, so you will be able to narrow down or get to the stable point before that. So say you made some commit, there were multiple files involved in that, and now you're not able to figure out which particular file broke your development or production code. So what you can do is you can just simply identify which commit you made. You can click on the symbol and you will be able to retrieve the stable point or the stable version of the software that was there and at that point of time. So this is the commit hash. So this was, say, a stable version at that point of time. So the next thing that we are going to look at is a pull request. So a pull request is a simple ask from one developer to the manager or to the repository manager is, could you please merge all my codes to this particular branch again. So I want to merge all the codes that I have been doing in the development branch to the main branch. So right now, if you see the differences, if you go to the dev branch, you will be able to see that we have 3 files over here. However, in the main branch, which is say your production code, or which is your final end code that's going to be consumed by everyone, you have only 2 files. So this is some change that you are proposing or that you have made, and now you want that to be merged with your main branch so that everybody can use that as a stable version. So you will go to this compare and pull request, or you can do it from the here itself for pull requests, and you can create a new pull request. Okay, over here you will be able to say from which branch do you want to pull all the codes to which other branch. Okay, over here you are able to see that they are able to merge these changes. Okay, so you can write a random note, random, or make it more descriptive in terms of what all changes are you asking for the changes to be. Then you can add a reviewer, any contributor who is a part of this repository can review your code and suggest if they want it to be added or not, or any changes, and then you can add a pull request. So once your pull request is created, and if you are the admin of this particular repository, you will be able to merge this pull request, or anyone who has the credentials for merging request in this repository will be able to merge this request. After these changes are done, you can either delete the branch in which these particular changes are made. So usually what happens is, if you're making a bug fix, you will create a quick branch out of it, make all your changes, push it back to the main code, and then after that branch is no more in use, right? So you can delete that branch. So we can go ahead and delete the branch, but I will just keep this branch for right now so that we can use it for some other sample ideas. Okay, so these are the basic functionalities that you can do via Git, and once there is conflict, you will be always be able to resolve conflicts in this manner. Okay. So let me create one conflict right away so that you will be having an idea how to resolve conflicts as well. Okay. Okay, so I'm directly updating this to the main branch so that we can simulate a conflict over here and then put it back. Okay, right now if you see the dev text in the main branch, it is already a step ahead with the development branch, because we do not have those commit histories in this particular branch. Okay. So over here you will be able to see that it is 2 commits behind main branch. So right now this particular branch do not have all the informations or all the changes that were made while you were working on this branch. Okay, so what we will do is we will go ahead in the VS Code, or you can directly do it from the GitHub interface itself, but I will just directly do it over here. Take a new line, unit, and I will do is okay. I will push it via GitHub desktop. I will commit. Great. So now Once you open this file, you'll be able to see that there are 3 lines over here, and this first particular line is different than what we have in our master branches or the main branches file. Now we are going to create a pull request. Create a new pull request from development branch to the main branch. Okay, so over here we now have a conflict. So it says we cannot directly or automatically merge it. You can still create the pull request, but you have to manually resolve these particular lines. Okay, I will say, okay, go ahead and create this pull request. Create a pull request. Now, in order to merge this changes to master, you need to go ahead and resolve these conflicts. It says which particular file do you want to keep. So I want to keep a random line with conflict along with the new line. So this is the final line that I want to keep in main. So I can mark this as resolved. Commit merges. Merge this pull request. Great. Okay, so now you will be able to see the third line and the first line in both the branches, since we have resolved the conflict from both these branches and merged them and made them parallel. Okay, so even if you go to the other branch, you will be able to see that though we have made some other line changes over there, we had written test notes instead of that. Since we now have resolved the conflict, now both the files are at the same stage. Now you can go ahead and say fetch your origin. Okay, and if you go ahead in your development in ID, you will be able to see that all the new changes are being pulled over here. Okay, great. So let us move ahead and see how we can use Git using our command line interface. So for that, if you have not already, you can go ahead to this particular link and download Git for your operating system. So I'm using Windows 7. I have downloaded and installed the Git version for Windows. Once you have that installed, you can go ahead in your repository. In the code section, you can just copy this URL for HTTPS cloning. Okay, and then in the folder where you want to clone your repository, you can open any command line interface. It could be CMD PowerShell for Mac OS. It could be your brew home. We'll just open the Git bash over here. With Git software, you will be having this Git bash installed along with it. Okay, so we'll just open that. And just to see that if your Git is working or not, you can just type git ---- version. So it will show that it's installed. If this particular command runs, then your Git is successfully installed. Okay. Then there are a few config settings that you need to do. So we will be able to do that in your later stages as well. So right now we can just git clone the repository. All you need to do is paste the URL and hit enter. So if it's the first time use for you, then it might ask you your email ID and password for GitHub. Otherwise, it will clone it directly. Okay. So once you have this cloned in your repository, in your folder in which you want to clone this thing, you will get the repository's name, and all the files will be cloned inside that. Okay. Inside this, you will have this .git file, which is able to track the history of all the changes that has ever been made to this particular repository. Once you have this open, you can go ahead and right click and open the bash cell over here. So once you open your CMD, you will be able to see the branch that you're working on. So right now I'm in the diff branch. Okay. You can create a new branch using git branch, a branch name, or you can check all the branches. Okay, right now it's in the main branch. Okay, you will be also able to see list of all the branches. So you can write git branch. It will show you the current branch that you're working in, and then you can also type git branch. I say it will show you all the branches available. So right now its head is at origin main. There is also a dev branch, and there is this main branch. So if you want to create a new branch, you need to write git branch. I want to create a branch named test, so I will create that. Okay, then I will git checkout to that branch. Okay, so it has switched to main or test branch. Okay, so in this test branch, I want to create a new file. Okay, say I want to create a file named test itself, and I want to do some changes in it. So I will just open this sample new test line. I will save this, close this. Now to check the status of my branch and what all changes have been made, I can just simply write git status. It will show me that this file has been changed. To add this file to staging, what you can do, if you want to add all the files to staging, you can just simply write git add dot. So it will add all the files that have been changed into staging area. Or you can simply write the file's name individually as well if you want to select some particular file. So I will just write test.txt as well. So it has added all the files. So I'll just check the status again. It has added one new file, test, in the staging area. Okay. Then what I need to do is I need to git commit this. I will write a new message with it, commit message, adding a new test.txt file with few lines. Okay. It will say that since this is my first time, I need to set my config and the username as well, so that the origin repository knows who is making these comments and who is making these changes. So I will go ahead and set those. So you can write git config -- global username as my username in GitHub. And user.email as my email ID in GitHub. Okay, now I can go ahead and make this commit. Okay, so it has made this commit. It is telling that one file changed. There's one insertion made, and this is the create mode. Okay, now let me go ahead and let's show you how one deletion can also be made. I'll just open this line. Test and then new line. Okay. So now again, if you check git status, it will show there is one file change. Then I can again do git add test, and I can git amend. Okay. Now it's telling there's one file changed. There's two insertion, one deletion. It is same as what we were seeing in the GitHub desktop. So any changes in a particular line is treated as a deletion and then insertion of that line again. Okay. Now what we can do is we can push all the changes to our main repository. Okay. So we'll say git push origin test. Okay. Great. So it has pushed all your changes to your origin repository. You can go to your origin, refresh the page, and you will be able to see a new branch over here, which is test branch. Great. So the next step for this is let us understand how we can work with a particular branch when simultaneous developers are working on the same branch. Okay. So this case is usually handled with GitHub Desktop already. But we need to understand how what all steps are there and what is the chronology of doing the steps. Okay, so suppose I'm working on my local branch. I already have made some copy. These are the files which are there in my copy of the local repository clone. Okay, but there's some developer who has added a new file, and the name of the new file, say test2.txt. Few lines here. Okay, and he has made these changes to the test branch, but I'm not aware of these changes yet in my local repository. Okay, and what I have done is I have created another new file in my local branch, which I have named as test3.txt. okay, so now what I need to do is first I need to check my git status. So it is telling me that I have added a new file. Okay, great. I will add this git file in my staging area. I'm adding all the files right now. I will just check again, verify again if everything is added or not. I will just git status. It has already been made. Now I will git commit this. Commit -m, adding a new file test2.txt. Okay, but right now I am not aware of all the changes that has happened intermittently or in the repository. So to do that, what we usually do is we git commit, and once we have committed, we pull the repository to our local again, check all the changes, and then push it back. This is auto handled when you are doing it via GitHub Desktop or any other client, but while you're doing it via the command line interface, you have to keep this in mind. Okay, we will git pull from origin test. Okay, so it has changed the new files, and it has pulled our latest origin repository to our local copy. Okay, once this is done, now you can go ahead and push your changes to your master. The remote location. Okay, so it has pushed all your changes to the final repository at the server. Okay, so let us see the commit history and how this chronology has worked out. So you had created some file test.txt and you have pushed that. Then you have added some new line in that file only. But there was some other developer who has created the test.2 file, but you were not aware of that since you do not had this stage in your local commits. Then what you did is you cloned it again after you have committed, and then you added this text 3 file, and then you pushed it back. Okay, great. So the chronology is, once you make some changes, you do it, you check your status of the file changes via git status, then you git add all those files to staging, then you git commit them, and then you pull the repository from origin, and then you again push it back. Okay, that is how the entire chronology in command line working is going to happen. After that, the pull request and merging it to the master remains same as we have discussed in the GitHub desktop overview. So with that note, this session comes to an end. If you found this tutorial useful, please do share this with your peers and friends. Give your valuable feedbacks in the comment section, and please subscribe to Naukri Learning for more such tutorial videos. Thank you. Have a good day.